Hi everyone, welcome back to my channel. So in this video I will be telling you about the switching, and I think that this is the most important concept in computer networks. So let's begin. So switching is nothing but using the routing table in order to find that on which path or on which interface I have to send my packet. That is known as switching. So that is identifying the path for a desired packet is known as the switching, so that the packet can reach up to the right destination. Okay, so in the computer network, switching is divided into three parts. We have circuit switching, packet switching and message switching, and the packet switching is further divided into virtual circuit and datagram. Okay, so we will discuss them one by one, and I will be telling you features of every type of these type of switching. So, and also in the end of the video I will be telling you some interesting facts about switching that are actually useful in your daily life. Okay, and I think you will find them to be quite interesting. Okay, so let's begin. So let's talk about the circuit switching. So it was used in early 1980s and it is completely absolute now. It is not used now. Okay, so if we talk about 1980s, then at that time every village or every town used to have only one telephone exchange. Okay, so if in that particular town, if any person want to talk in the other village, he has to come to that particular telephone exchange. Okay, so I have taken this example. Let us see. These are the three villages A, B, C, and these are their telephone exchanges. Okay, so suppose that from the village A, a person comes as X, and he will come to this telephone operator, whoever is sitting at this telephone exchange, and he will ask this person that I want to talk in the village C from my relative. Okay, so if it is possible at that time to make call, I mean that if no any person before this X is waiting for the call, then this telephone operator will allow him to make a call. Otherwise what will happen, if a lot of people are already waiting for their calls, then it will note its name in a log and serially his number will come, and in those times it actually takes 1 or 2 days when the number actually comes that you are allowed to make a call. So you can imagine that it was really hard in those times. Okay, so suppose that this person is allowed to make a call, I mean no any person is waiting. So what this telephone operator will do, he will inform the telephone operator of B that I want to make a connection with a village C. So in this way they will take the physical wires and they will be making connections from one village to other village like this. Now here will be an operator, a telephone operator. He will also do the same thing. Okay, and in this way this X person will be able to talk from his relative in the village C. So in this way they just take the physical wires and make the connection between their telephone exchanges and between the villages. Okay, so this was the concept of circuit switching. Okay, so I will be telling you some more points about this. So let's see. Yeah, so I have already told you that it was used in early 1980s and it is completely absolute now and no one use it in these days. Okay, and another thing is that no headers are required. So it means that it is like a train, only a single path is there and no any special headers are required in order to tell the route to the data. Okay, so that's why no any header is required, because whatever packet we are sending, it will go in one go without any breaking, without any fragmentation or segmentation, anything like that. Okay, so this was the second thing, and one thing is that no reordering is done. So as I have told you that it is like a train. Okay, so we are not dividing our data into several parts, so that's why this is the reason at the receiver no any ordering is required. Ordering means, suppose that I have received various parts from something and then I will rearrange it in the particular sequence. So it is not required here because we are not dividing our data. Okay, so these are some of the things for circuit switching. Next we will see the packet switching. So let's begin. Okay, so let's talk about this packet switching. So packet switching is the most important concept and it is actually used very widely nowadays. Okay, so the first thing is headers. So in packet switching, headers are there that are actually used to tell the paths to the various segments of our packet. Okay, so and this is the reason that we don't need any physical wire here. Okay, so as we are using the physical wire in circuit switching, but here no any physical wires are required. So I have mentioned in my second point that no any physical wires are required. Okay, and the third thing is pipelining, which is the most important concept here. So please understand this pipelining very carefully, because this is the heart of this packet switching. Okay, so let's see this. Yeah, so suppose that I want to manufacture a car, right? And on the very first day, let us assume I just send it to the body department. They will manufacture the body of my car. Then on the next day, I send this body to the tires and engine department. Okay, and on the next day, I send my car to the painting and testing department. Okay, so in this way I will get my finally output. So you can see that in order to manufacture one car, it is taking me 3 days, right? Now suppose that with the same scenario, if I want to manufacture 100 cars, then how much time it will take? 100 into 3, which is actually 300 days. And I think it is a very long duration, right? So we will see the same concept with the help of pipelining, and you will see that the number of days have been reduced by a very large average. Okay, so let us see the same example with the help of pipelining. So when it comes to pipelining, what I will do, suppose that I started manufacture my first car. Okay, so I will send it to the body department and they will manufacture it body. So when the first car will be sent to this department, then this body department will be completely idle, and instead of sitting idle, it will just starting the manufacture of the second car. Okay, so basically when a first car will be here, this body department will already start the manufacture of second car. So it means that when our first car will be here in the painting and testing department, our second car will already reach here in the tires and engine department. And when our first car will be completed and comes as an output, then on the very next day, that is the next day to the output of this car, second car will come on next day. So on next day, second car will come, and similarly on the next day to the second car, third car will come. So in this way it will happen. So basically if you see, if I talk about my first car, it took me 3 days, right? But if I talk about my rest 99 cars, suppose that I want to manufacture 100 car and I talk about the first car, it will take 3 days, and how many cars are left? 99. So they will take 99 days, because each car is coming in next to next one day. Okay, so it is taking 102 days. So you can see the difference. When you are actually implementing the same thing without pipelining, it was taking 400 days for the manufacturing of only 100 cars, but now it is taking only 102 days. So this is the difference, and this is the essence of pipelining. Okay, so let's see more on this packet switching. Yeah, so let's see more about this packet switching. As I have told you that it is divided into two parts, that is the virtual circuit and datagram. They both are the very important concepts in today's world. So I will tell you the major difference between them, and the major difference between them is this virtual circuit, it is connection oriented, and this datagram is connectionless oriented. That is, so let me write it down. So as you can see, it is connection oriented, this virtual circuit, and this datagram is connectionless oriented. So when we generally talk about these kind of terms, then the first thing that actually came to our mind that we are talking something about the connections or something wires and all kind of stuff like that. But it really doesn't mean that. When we talk about the connection oriented, it means that buffer reservation is here. That is, we are actually saving some extra space. That is known as the connection oriented. And connectionless oriented means that we are not saving any kind of buffer, we are not saving any extra space. Okay, so let me tell you or explain you with the help of an example. So actually what happened in virtual circuit is, suppose that these are the stations or the switches. So whenever the header of our packet will pass through like this is our packet, and since we are talking about the packet switching, therefore a header will be there. So whenever this header of this packet will reach at this particular station or a particular switch or router, it will order it that my more friends are coming or my more parts are coming, so please reserve some space for them. So basically this switch will definitely preserve some space for the remaining parts. So this is nothing but the connection oriented. Okay, and when this space reservation is not there, then it means that we are talking about the connectionless oriented. Okay, so this was the major difference. And other differences are, it is more costly, and this datagram is less costly. Okay, now since this space reservation is there, due to which it is more costly. Okay, and that is the reason that it is less costly. Okay, another major difference is when we talk about the packet transfer in this kind of switching, then as you can see here, the space is reserved, and due to which a packet will be followed by a single path. Okay, each and every packet will be gone through the same path. But when we talk about this datagram, then since it is connectionless oriented, then definitely every segment of packet can follow any part. Suppose that this is our data and it is 3 parts of this data, right? This is our data. So this particular segment can follow this path, this particular segment can follow this path, or this segment can follow this path. Okay, so in this way every segment of the packet will be following a different path. So this is also a difference in these two. Okay, and now as you can see that here every segment is following a single path. Okay, therefore here no packet loss is there, no packet loss, because they are in a same path and they are following each other simultaneously. But when we talk about the datagram, since every segment of the data is following an independent path, it means that here there is a possibility that a packet may get lost. Okay, so let's see this. Here packet loss can be there. So these were some of the things that are related to packet switching, I mean the virtual circuit and datagram. Okay, and now I am going to tell you some of the interesting facts that are related to these virtual circuit and datagram. So let's see them. Okay, so as you have experienced that whenever we talk about the voice call and data call, the data call is always very cheaper than the voice call. I mean to say that we have a voice call. Voice call is nothing when we try to call someone and we talk to that particular person, and we have a data call, that is the MBs and GBs we are actually spending. So this is actually cheaper and this is costlier. So actually the reason behind their cost is only the virtual circuit and datagram. The reason is that when we talk about the voice call and we make a call to someone, then what happens is the ring goes in a single manner and follows the same path. And I have already told you that in the virtual circuit every segment of the data will follow the same path due to the reservation of space. So basically this voice call is actually dependent on the virtual circuit, or we can say it is the application of virtual circuit. And this data call, here no any reservation is made, and it is the application of this datagram. Okay, and now as I have told you that in virtual circuit a lot of buffer is reserved for the rest segment of data. So basically due to that reservation of space we have to pay our extra rent. Suppose that its cost is X and its cost is Y, but since it is in virtual circuit, this voice call is in virtual circuit, so we have to pay an extra rent due to the reservation of space, that is X plus R, where R is the rental cost, and that's why it is always very greater than this data call. So this is the reason behind this. Okay, now yeah, so another thing is You may have seen that various applications like Facebook, WhatsApp, they provide us the facility of the voice calls, right? And now you may ask a question that is actually very cheaper. So why to make a call? Why to buy a voice call? Since these applications are already providing us that facility at a very cheaper rates. So let me tell you the difference. Actually, when we talk about these kind of softwares, then what they does, they just take your voice data, okay, and they actually transfer it like it is actually going through the datagram medium, right? So basically they just treat it your voice like it is a datagram service. And the protocol used, that is known as the VoIP, which stands for voice over internet protocol. So this is the reason. So basically whatever the voice data you are sending, it will be treated like you are using a datagram service. So that is the thing that this kind of software uses, okay. But you may have experienced that the quality of such kind of calls is very poor, and the reason is that since it is the datagram service and every packet can follow the any path, even a packet may get discarded in between, due to which the quality is very atrocious, okay, or very poor. So that's why if you really want to make an important call, so never go with such kind of calls that are provided by the softwares, because it may be possible that your communication will not be effective. So whenever you are talking to an important person, always go with the virtual circuit services, and whenever you are talking from a person who is least important, then you can go for the software calls, okay, because the quality will be quite poor. So these were the concepts. I hope that you like this video, and if you like this video, then please make sure to give a big thumbs up to this video, and please subscribe to my channel and share this video with your friends, your family, okay. Thank you.